Our learning goal today states, I can solve compound inequalities, which you've already worked with in your SB3Rs, and graph their solutions. So compound inequalities are what? Devin?
Two simple inequalities that are joined together with the word and or the word or.
Okay, so there's two inequalities involved in a compound. So let's write two, and they are simple inequalities. We'll just call them two inequalities. So simple meaning when there's just one inequality sign involved. That's just a simple inequality, but once we combine two inequalities like that, and we join them together, they become a compound inequality. And what was the end of that, Devin?
With the word and or the word.
Yeah, so either we will have the word and involved in them, or the word or involved in them. And do they mean different things?
Yes.
They do. Remember there were some other vocabulary words in there. Tell me something about the and compound inequalities. Tell me something about the and compound inequalities from your notes that you took. Okay, Devin.
It's the overlapping region.
It's the overlapping region. What's the vocabulary
The
word for that called? The intersection. So the intersection of the solutions of the two simple inequalities that are making up the compound inequality, where they intersect, where they overlap, the solutions that they share become the solution set for an and compound inequality. Well, now tell me something about the or compound inequality then. Tell me something that you learned in your note taking about the or compound inequality. Austin?
The combined regions of the inequality.
Okay, the combined regions, so in other words, you put them together and everything that they have in common works, or do they not even have to have anything in common? What's it called? What was the vocab word for that one called? Union. So in an or compound inequality, we put the solution set from one together with the solution set from the other. We call it a union, and they don't have to have anything that they share. They're going to come together and create the solution set for the compound inequality or, because or means what? What does or mean? One or the other. Do you have to satisfy both?
No.
If your parents say to you, clean your room or unload the dishwasher, do you have to do both things? No. But if they say, clean your room and unload the dishwasher,
They want you to.
they want you to do both. So we have to understand the difference between the and the or in our compound inequalities also. So compound inequalities are graphed on the what? Same number line. Same number line. So these two simple inequalities combine onto the same number line. We show the intersection or the union, whichever one it is, on the same number line. And compound inequalities are the values where both inequalities are true. So whatever the solution region shows for the and compound inequality, it better make both parts, both simple inequalities true. Remember, it's an intersection. So here's an example of an and compound inequality. Can somebody read that for me? How is that read? How do you think that example there is read? Devin?
-3 is less than or equal to x, and x is less than 3.
Okay, good job. -3 is less than or equal to x, and x is less than 3. In other words, it has to, any solution for this compound inequality has to satisfy both parts of that. The number has to be, can we read that from the inside out also? X is what? Let's go to the left end. X is greater than or equal to -3, and
X is less than 3.
okay, so it's only those numbers that satisfy both conditions that are going to be solutions for this one. So when we talk about this, we can really break it apart like this and say, just like we just stated, x is greater than or equal to -3, and x is less than 3. So whichever numbers satisfy both of those get to become part of our solution region. So we're not gonna do integer neighbors when we do compound inequalities. We're gonna do the endpoints involved in each of the two simple inequalities. So in this one, they are -3 and 3. So let's first of all decide, is -3 a solution?
Yes.
Yes,
Okay, does it satisfy both?
yes.
Okay, so what part of the first one does it satisfy? -3. What part of this one right here does it satisfy?
X.
Well, yeah, it couldn't go in for X, but what part of the inequality case?
It's not equal to.
It's the equal to. It satisfies the equal to part. Okay, what part of this one does it satisfy?
The less than.
It's less than 3, isn't it? -3 is less than 3. So we can shade in then our circle at -3. It is included in our solution set. How about the other endpoint, 3? Is it included?
No.
Josh, why not?
No, because it's not equal to, it's just less than.
Okay, because it's just less than, okay? But it's greater than -3.
That's not part of the solution.
But it's not what?
Equal to.
Equal to.
But it's not less than 3. It's greater than -3, but it's not less than itself, is it? It's not less than itself. So it is an open circle. Okay, what other numbers would satisfy then? Would the ones like -4, -5, would those? Okay, why does the -4 satisfy it?
Because it's not greater or equal to -3.
Okay, because -4 is not greater than -3 or equal to -3. Okay, so we can't shade that side. How about the other side of 3 then? Are there any numbers like 4, 5, 10, any of those numbers that satisfy both of them? Okay, which part doesn't it satisfy?
X is less than 3.
The x is less than 3. So if we chose 5 for instance, 5 is not less than 3. Okay, well then what numbers are? Are there any other numbers other than -3 that are solutions?
All numbers in between.
All numbers in between?
-3
And +3, all of those guys? Can you think of any number in there that might not be greater than -3 and at the same time less than 3? No. Okay. This is typical. I notice it did not say always. This is typically how an and compound inequality solution looks between two endpoints on the number line. Typically. Not always, okay, so don't think that just because it's an and, it will always be that way. Okay, let's explore the or then. The or compound inequalities are the values where, what? Either one or the other. Just like me saying, unload the dishwasher or clean your room. You get to pick either of those choices. So, of the two inequalities, so whichever, if it makes one of those true, it's a solution. AJ, join us. If it makes one of them true, it's a solution. Okay? So, example. Somebody, AJ, why don't you read the examples for us on this one?
X is less than or equal to 2, or X is greater than or equal to 7.
Okay, so this is a intersection or a union one? Union, meaning you bring them together on the same number line. Okay, so how about our endpoint 2? Is it a solution?
Yes.
Okay. How about our endpoint 7? Is it a solution?
Yes.
Okay. But wait a minute, 7 is not less than 2. So it satisfies this part, it satisfies the equal to part of this one, but 7's not less than 2. 7, I don't think 7 is less than 2. But what's the reason that 7 can be a solution in this one? Because it's or. It has to satisfy one or the other. It does not have to satisfy both of them. So that's important that we understand that. Okay, well, what other numbers? Are there any others that would satisfy one or the other? 8 would? Okay, 8 would satisfy the second one, wouldn't it? So that would mean any number greater than 7 should? Okay. And any number less than 2 should also. Because again, we're combining the two on the same number line. Do they share any in common?
No.
No, they don't have any overlap on it. And there doesn't have to be for an or. There can be, but there does not have to be for an or. Okay? So typically, again, I'm gonna say typically, or compound inequalities kind of go out from the endpoints. Typically, the solution regions do. Okay, questions at all? Okay, then let's see how well you can write these compound inequalities then that the graph shows. After doing your own note taking. Anybody want to take a stab at number 1 here? AJ?
X is greater than or equal to -5, and X is less than -3.
Okay. So, everybody agree? That would be all numbers greater than or equal to -5 satisfy it, and the ones less than -3. So, in between there. Okay, but this is not how we would probably see it written in an answer bank. They don't typically write the and ones using the word and. So how could we rewrite this out? You know, AJ, how you could rewrite it without the word and in it? Okay, Austin?
-5 is less than X, and then it would just be, or equal to X. And it would just be leave the X, and then it's less than -3.
Okay, that's how we would combine it. So the X goes in the middle, because we can read from the middle out. If we read from the middle out, we are talking about that this is the X is greater than or equal to -5. When we read from the middle out the other direction, this is the X is less than -3. So that's how we're going to see it in an answer bank. So that's how we're going to write them, okay? Okay, how about our next one? What would our next one be? Let me hear some new voices in here. Okay, Josh.
X is less than -4, and then
And? So an and?
oh wait, no. It's
You want me to take away the and? Now you want an or? Okay. Or?
X is greater than 4.
Okay, you would typically write this all in one line, but I'm running out of room, so I'm going to move down here. Okay. You guys agree? That's what this graph tells us? Okay, is there any overlap?
No.
Okay, if there's no overlap, chances are that then can't use the word and, can we, like Josh is trying to? Because and means what?
If there's
Overlap, there's intersection. We're looking for just union, combining them together in the same statement. Did the book show you another way to write these? These or ones? In your SQ3 hours, did the book show you a different way to write the or ones? Like we wrote AJ's and one. We said, you know what, this is how it would typically be in an answer bank. Is there a more typical way they would write this one in an answer bank? Okay, I'll give you the answer. No, there is not. But here's what students try and do, and I counted wrong. So I want you to pay attention here, okay? We will not see an or compound inequality written like this. Okay, X, and then we would say is less than -4, is greater than 4. We will not see an or compound inequality written that way. We will not combine them and let them share an X. Okay, so don't do it. -4 is greater than X, and X is less than 4. That's not gonna be how you would ever see it in an answer bank. So let's not get in the habit of writing them like that. Just use the word or. Okay, do the last one on your own. What would it look like? Okay, Brayden, what you got for this one for me?
-1 is greater than or equal to x, which is less than or equal to 1.
Okay, do you guys agree with that?
No.
What do you wanna change? Devin?
Well, the first inequality is wrong. It should be -1 is less than or equal to x.
Okay, because if we read this from the inside out, we're saying the shaded region X. Always think of X as the shaded region, okay? So the shaded region is less than -1. Is it shaded to the left of -1? It's not, is it? So we do have to switch this inequality symbol around to read is less than or equal to. -1 has to be smaller than all of the numbers in the shaded region. Is it? Is -1 the smallest one shaded? Yeah. And then the largest one shaded has to be 1, because it has to be, the shaded region also has to be less than or equal to 1. So then, okay, so we have to make sure that we know how to write these properly. Now, here's the thing that can take a whole point away from you, or get on a standardized test when you're choosing from a multiple choice bank. Are they forgiving and say, oh, well, they were close, I'm gonna give them say that this answer is right? No. So the really important thing that we have to pay attention to, in these especially, one of the things that can just cause the whole thing to be wrong is if you do not pay attention to these endpoints, whether they're shaded or not, whether they need an equal to sign or not. You have to make sure that you pay really close attention to that and take that into account when you are writing your inequality symbols, whether you should have the equal to bar or not, okay? So be really careful of that. So any questions? Okay, let's go do some solving then. Did you have a question, AJ?
No.
Okay. So, when you're solving AND inequalities, our intersection ones, whatever you do to one region, whatever you decide you're going to do to start solving it, whatever you do in one region, you also must do to the remaining 2. Because how many regions are there in an AND? 3. There's the left end, there's the middle, there's the right end. There are 3 regions. So once you decide to do something, you look at it and you say, I want to get rid of this, then you've got to make sure you do it to the other 2 regions, okay? So, what should be our focus though? Which region should be our focus? Oh, yes, that should be our focus. We should care less about the other 2 until we're actually having to do something to them. So what should we do in this number 4?
Subtract 2 to both sides.
Subtract 2 from
Both regions.
all 3 regions. All 3 regions. So in reality, we got going on here, we got 3 regions. We got 3 sections. So what does the left end become? -3 take away 2. -5 is, did we do any multiplying or dividing? No, by the way, you still have to keep that rule for multiplying and dividing by negatives, okay? Even though we're not working with simple inequalities, we're working with compound. Is x by itself now?
Yeah.
Okay, and is less than, and is less than 5, okay? Now, do not think that it'll always be that if you have, like, let's say -5 at one end, the other end's going to be a +5, the opposite of it. The endpoints do not have to be opposites of each other, okay? So don't get, so that you just don't even do the math because you think, you know what, it's got to be the opposite of it anyway. So let's circle that, that's our solution. And now let's graph it. Do you have to have integer neighbors for compound? No, you need the what?
Endpoints.
The 2 endpoints. We're going to have 2 endpoints. -5 a solution? Okay, because it doesn't satisfy what? The what? Doesn't satisfy the x is greater than -5? Is -5 greater than itself? No. How about the +5? No. Which part doesn't it satisfy? The right end? Is 5 less than itself? No, okay, then what numbers are greater than -5 and at the same time less than 5? All the ones in between, okay. So this is a typical compound inequality and graph. Again, don't get those so to the point that all you do is just automatically shade between the two of them. Process through and make sure that's where you should shade, because it doesn't always turn out that way. Okay. Number 5, what would we do first in this one? Okay, now, some of you like to, for some crazy reason, you like to take care of the multiplication first, or the division, whichever, like in this case, we would have to divide by 2 to get rid of the 2. Well, the same rule's gonna apply. If you decide to divide first, what do you have to do? Divide every piece. So there's a -3 to be divided by 2, there's a 2x to be divided by 2, there's a 1 to be divided by 2, and there's a 9 to be divided by 2. Would that be a good choice in this case?
No.
Not at all. So we're going to subtract 1 from all 3 regions instead. Seems like a more sensible way to go about it. What's the left end become? -4. What's in the middle?
2x.
Okay, bring down your inequality symbol, is less than or equal to. And bring down your is less than symbol, and what's the right end? 8. Okay, now what?
Divide by 2 on all 3.
Yeah, now we're going to divide all 3 by 2. You guys are the laziest work showers I've had, I think, my new 9th grade class this year. So will you bring every piece down? If you don't keep dragging that inequality symbol along, you're gonna forget about it. So what is this -4 divided by 2? What's that?
-2.
-2. Do we need to reverse the symbols?
No.
No, we did not divide by a negative. X is alone in the middle. 8 divided by 2? 4. Oh, note, are the endpoints opposites of each other? No, they are not. So again, you don't want to get in the mindset that the endpoints are going to be opposites of each other, even though opposite does happen. Okay, how about -2? Is it the solution?
Yes.
Because it satisfies both parts? Okay, it's equal to itself, and it is less than 4, right? Okay, how about 4?
No.
Okay, what part doesn't it satisfy?
Right.
The right part, it's not less than itself, is it? Okay, what numbers do satisfy it then?
Any number.
-2 to 3.
Because all numbers greater than -2 and at the same time less than 4, that's what you should be saying to yourself while you're shading it. Does it really, am I really shading what it says? Okay, don't be fooled. Questions on the and solving? Okay, let's do some ors then. When solving or inequalities, solve each independent of the other. In other words, you can't have the same thought process for both of them. There's not going to be regions. There's going to be 2 simple inequalities to solve. So we just take them one at a time. First one, what are we going to do? Subtract 2 from both sides. Now we're back to sides because we have simple inequalities. So we now have 3x is less than or equal to what? -9. What's our next move?
Divide by 3.
Divide both sides by 3. Are we dividing by negative?
No.
We're dividing into a negative. Does that change the sign?
No.
No, it does not. Only when we're dividing by a negative. And do we get -3? Okay. Well, now we solve the other one. Or, put the or here so you don't forget about that this is an or one. What do we have to do to this one? Subtract 4 from both sides. And some of you might be in a panic and say, oh, wait a minute, oh dear.
0.
0. Remember, 0 is the solution, isn't it? So let's just drag that down here. Let's say x is greater than or equal to 0. That one was so easy to solve. So here's our inequality, our solution. Now let's graph it. What will it look like graphed? Are you with us, Bree? Good. Yes, Devin. You want to graph it?
Yeah, I can
Okay, we'll graph it. Go for it. So this is the only one we're gonna practice at this time. Can this algebraic statement, the way it's written algebraically, can it be combined with one x involved is all? Why not?
It's a word.
Because it's an or one. The or ones, we are not going to combine them. Okay, thank you, Devin. Do we agree with him?
Yeah.
Okay. No questions? You might feel like you're getting a little reprieve here, getting to solve these compound inequalities. Right? Doesn't that seem a little easier? Some of the multi-step ones we've been doing, so-called simple ones we've been doing. So no questions? Okay, then let's get going on your homework.